this video, we're going to look at data transformations. So far, we've spent a lot of time looking at visualization. And visualization is a very important tool for describing data, but unfortunately, it's going to be rare that you get the data in exactly the right format to start with in order to make plots. So often what you'll find is you'll need to manipulate variables or reorder observations to make the data a little bit easier to work with. And when people are first starting working in data analysis, I think there's this temptation to edit the CSV file. So let's say that you've got something coded as 0 and 1 and you want it instead to be yes and no. Some people will go in and exchange the or probably change the file in Excel before reading into Word. And this is something I really want to caution you against. So typically what we like to do is start with, not just what we like to, really what we should do is whenever we get the data file, so like your CSV or your Excel file that's on your computer, you don't ever really want to change that file. You always want to keep it the same. And the reason for that is for reproducibility. If we make changes to that file, it could be hard to then send that file to someone else to maybe repeat the exact same results based off of the original file. And so what you really want to do is make all of those changes using R. So that way somebody could look at your code, see exactly what was changed, and if there are any mistakes, it's a lot easier to spot than if the original file itself was changed. So in general, we don't want to change the CSV or the Excel file. Instead, what we want to do is we want to write code in R that's going to make these changes that we need. And again, this helps with reproducibility, and it also helps safeguard us against certain mistakes. So we're going to look at a package that can help us do this. It's called dplyr. It's a part of that Tidyverse. So if you'll remember, ggplot2 was part of the Tidyverse, and all those packages in the Tidyverse, they share a common philosophy of data and R programming, and again, they're designed to work together naturally. So the first thing that I'm going to do here is just load that Tidyverse package. And so remember that if you get an error here that says, hey, I can't find the package, this is because the package first needs to be installed. So you can always do that by going Tools, Install Packages. But if you've already installed the Tidyverse, then you don't need to do this every single time you open up R. Typically, I only need to reinstall a package if I update my R or if I'm working on a computer that I don't typically work on. So one thing to keep in mind is if you do get a conflict message, dplyr does overwrite some functions in base R, and so it's the filter and the lag function that get rewritten. And if you remember, we've seen where that's happened before when we looked at that MATLAB package several weeks ago. All right, so the data that we're going to work with comes from a package that's called the ISLR package. So the first thing I'm going to do is again load that package. Now I already have it installed on my computer. You probably don't already have it installed. So again, just as a reminder, we can go to Tools, Install Packages. You're going to look for the ISLR package and you'll want to install that. Alright, so we're going to load it. Here I just get a warning. So again, here the VCD, the hitters function is masked from the VCD package. We're not going to use that function, so that's perfectly fine. And then you'll also sometimes see a warning message just telling you that this package was built under a previous version of R than the one that you're working with. So the data set we're going to work with is the car seats data set. So I'm going to use this function just to pull it forward so that R knows I am going to use this data set and I would like it to populate into the environment. And then I can read about the data set by using the question mark. So here we have a little bit of information about this data set. This data set looks at the sales of car seats, and we can see that we have 400 observations with 11 variables. And so looking through here, we can see there are several variables. One thing that I always recommend with a data set before you ever start working with it is we always want to be familiar with what types of variables are in the data set. So for example, sales is unit sales in thousands at each location. So I know that that is going to be a quantitative variable. Comp price, price charged by the competitor at each location, that's going to be quantitative. We've got education level at each location, that's going to be categorical. Urban is a factor with levels no and yes to indicate whether the store is in an urban or rural area. Again, that's going to be categorical. So just going through each of these and making sure that you know whether or not each of these is categorical or quantitative is very important, because depending on the type of variable, that tells us what types of summaries and visualizations are appropriate for those variables. So for example, categorical variables, we might use bar charts, pie charts. For a quantitative variable, we might use things like box plots, histograms. If we're comparing two quantitative variables, we could have scatter plots. So really those types of variables dictate how we're going to summarize and visualize those variables. All right, so we're going to start out by just looking at some dplyr basics. And so we're going to focus on 5 functions over this week and next. And those 5 functions are filter, arrange, select, mutate, and summarize. And so again, these are very helpful when it comes to cleaning a data set or getting a data set in a format that we need in order to be able to analyze the data. And this is sometimes called wrangling data. They're all going to work in a similar way. The first argument, very similar to a ggplot, is going to be the data frame. But unlike ggplot, we're not going to have those plus signs and add-on layers. The arguments that follow the data frame are going to describe what to do with the data frame using the different variable names. Now notice here, when we use these functions, we are not going to put the variable name in quotes, and this is going to result in a new data frame. So the first one that we're going to look at is the filter function. So what the filter function will help us do is it will help us pick observations based off of their value. So in the car seat data set, there was a variable called urban and another one called US. And so remember that this is going to have levels no or yes to indicate whether or not the store is in an urban or rural location. And then US is yes or no to indicate whether the store is in the US or not. So what we could do is we could use the filter function, and what the filter function is going to do is the first argument is going to be our data set, so in this case car seats, and I want all of the observations where urban is equal to yes and US is equal to yes. So in other words, I'm going to pull out all those observations that correspond to stores where the store is in the US and in an urban location. And notice here we are using that double equal sign. Remember that a single equal sign is an assignment in R, whereas a double equal sign is a logical argument that asks the question, are these two things equal to one another? So if we run this, what happens is the new data set that it creates, which is the data set that has yes for both the US and urban, it gets populated down into the console. And so I move my window here. Let me run this again just to make it a little bit easier to see. So if we scroll up to the top, notice here we have observation 1. Here's the value for sales, the other variables, and then at the very end we have urban and US, and notice those are both equal to a yes. We got observations 2, 3, 4, and then notice that 5, 6, and 7 got skipped. The reason 5, 6, and 7 are not included is because each of those observations had a no for either urban, US, or both. So the only observations that are maintained here are those that have yes for both US and the urban variable. Now running filter by itself like this isn't very useful, because what it does is it just prints that piece of the data set to the console. We can't actually do anything with it. So what would be a better thing to do is to assign it to be equal to an object. So here I'm going to call it car seats underscore urban underscore US. And the reason that I'm naming it this way is because I'm starting with the original car seats data set. I'm pulling out those observations that are urban and those that are in the US. So I like this naming convention because it reminds me, oh, that's what I'm doing here. You don't have to follow this convention. You can use other names here, but this is just something that I'm using to help me keep track of what's going to be in this new data set that I'm creating. And so I always recommend when you create object names, create object names that make sense to you and remind yourself that, oh, this is, what's going to be in this data set. So let's run this line of code. So notice this time in the console, we don't get that big printout, and that's because what was printed here is now assigned to be car seats underscore urban underscore US. And if we look here in our environment, we can see that that new data set appears. Now you always want to do what I call like a bit of a sanity check. Does what we got here make sense? So what we did was we took our original data set, which was car seat, had 400 observations with 11 variables, and we have subsetted it to only include those observations that have yes for urban and yes for US. So in that case, I would anticipate there to be fewer than 400 observations in this new data set. And I see that there's 186. But I haven't made a reduction in the number of variables, so I still anticipate there to be 11 variables, and we can see that that is still the case. And so just like any other data set we've worked with, I can click the drop down, I can see those variables that are in it. I can also view this data set by using the view function, and don't forget that view has a capital W. And so here is my new data set that was created, and notice as we scroll down, urban and US only take the values yes for this particular data set that we created. Now I could create another data set, but let's say that I don't want the store to be located in the US. In other words, I want the ones where US is equal to something other than yes. So in this case, I'm going to call it car seats underscore urban underscore not US, because these are going to be the observations that are not in the US. I still have my filter function. I'm going to start out with the name of my original data set. I want the observations where urban is equal to yes, and I want the observations where US is not equal to yes. So the exclamation point in the logical operators is a negation. So this means not yes. Now in this case, US only takes two values, yes or no. So if I say not yes, that's going to pick up all the no's. I could have just as equally here put equals, no. These are going to result in the exact same thing because US takes two values, yes and no. Now when you need to be careful is if you have a variable that can take more than two values. And so in that case, it would not be the same to do this. So not equal to would give you everything other than the value that you put in, whereas equal to is only going to give you exactly that value that you specify. And which one you put there will be dependent on what it is you're trying to do. So let's run this one. And again, notice now I've got that data set, I've got fewer observations, we've got 11 variables, so that looks correct. And then again, I could use the view function. And in this case, notice that for all of these, urban is equal to yes, and US is equal to no. All right. You can also combine logical operators, and you can do this using the AND symbol. So if you want to filter it based off of two things, so in this case, I'm going to have car seats urban US 2. So I just put, the number 2 after this, because I'm going to distinguish it from this one I made up here. So in this case, I want all of the ones where urban is equal to yes and US is equal to yes. So let's see what happens here. So notice in this case, this is my car seats urban, and you can't see it here, but this is the one that has US 2. Notice it has 186 observations of 11 variables. So having the AND symbol in the filter function is the same thing as using the comma. So these two lines, line 56 and line 48, are going to produce the exact same output. Now instead of AND, we might want to combine them with an OR. So I want all the observations that have urban equal to yes or US equal to yes. And this is going to be the inclusive OR, so that means it could either have urban equal to yes, US equal to yes, or yes to both. And so the vertical bar, that is the or symbol in R. So here I'm going to call this car seats urban underscore US3. So again, just to distinguish it from the one that I have above. And here is that new data set. And if we look through here, notice that we have the yeses and the yeses like we did before, but we now also have those that just have yes equal to one of the variables. And then finally, another thing that we could do is we could find the observations that are in a set. And so what do I mean by that? To show what I mean by that, let's look at the education variable. So to start with, I'm going to make a table of the education variable from the car seats data set. So notice that this variable takes the values 10 to 18. And we could also always go back and we could read about it. So it just says education level at each location. So that's not entirely clear based on this data set what that means for education level at each location. So just really see what that is. We'd probably want to visit this source and read a little bit more about that data set. But for now, we can see that education level ranges from 10 to 18. We have 40 observations at 18, 40 at 14, 48 at 11, and so on. But let's say that I wanted to subset this data set so that it only included the observations that have education at either 11, 12, or 13. So again, using the filter function, I have the name of the data set, the variable that I'm interested in, and then what we have here is an in operator. So this is percentage sign in percentage sign. And what this operator is going to do is it's going to find all the values of education that are in this vector that I created here. So notice this vector is a vector that has the number 11, 12, and 13. And so again, let's run this and view the data set. So looking at the education variable, as I scroll down, notice that I only have the education variable where, I only have observations for which the education variable is equal to 11, 12, or 13. And then if we make a table of this new data set that we just created, notice that we only get 11, 12, and 13 for the education values, and we have 48, 49, and 43. And notice that the counts for these three match the counts that we have up here. So we know that we really did pull out those observations that have education level equal to 11, 12, or 13. Now, when making comparisons, just as kind of a word of caution here, we do want to be careful with missing values. Missing values can make comparisons kind of tricky. So recall that an NA represents an unknown value. So almost any observation involving an unknown value is also going to be unknown. So for example, if we have an NA greater than 5, well, that's unknown because we don't know what the value of the NA variable is. We have 10 equal to NA. That's also NA. We don't know if that's true or that's false because the NA means missing, and you can see similar operations down below. So here's an example from the book. So let's let X be Mary's age, and we don't know how old she is. So we set X equal to NA. And let Y be John's age, and again, we don't know how old he is, so we'll set that equal to NA. And so the question is are John and Mary the same age? And R is going to give you back an NA because we don't know either of their ages. So one way to determine if a value is NA is to use the is.NA function. So notice we had set X equal to NA, so we ask is X equal to NA, and the value is true here. We can also use the is.NA function combined with the sum to figure out if there are any missing observations in our data set. So notice since the sum is here, the car seat data set doesn't have any missing values, so we don't have to worry about that for this particular data set. Now in the future, we're going to spend part of a module looking at how to visualize missing values in a data set. When you're working with real data, there's almost always going to be some missingness. So figuring out where the missing values in your data set is very important. And so we'll look at ways to find those missing values, but also how to visualize the missingness. So in other words, we can kind of visualize where the missing values occur and kind of help use that to determine if there's going to be any implications in our analysis. So that's a little bit about the filter function. Next, we're going to look at the arrange function. And the arrange function, what it does is it's going to order observations by their values. And so it takes a data frame and a set of column names to order by. And if you provide more than one column name, each additional column will be used to break ties in the values of preceding columns. So for example, if I wanted to take the car seat data set and I wanted to arrange it by price. And so just as a reminder, if we come over here and we look at price, that's the price the company charges for car seats at each location. So similar with the filter function, what happens here if we don't assign this to be a data set, I'm going to run it again because I made this window bigger so it all prints. There we go. So very similar, again, to the filter function, if I don't assign this to be a new data set, it's just going to print it down in the console. So it's not the most useful, but it does help us initially see what the arrange function is doing. So notice here, if we come over to price and we look at these values, we can see as I scroll down, price is increasing. And so the entire data set has been ordered based on the variable price. And then coming over here, we can see that the 43rd observation had the smallest price, and then the 126th, 368th, and so on. So for these functions, and you saw this with the filter function, these values all the way over on the left, when you print these in the console, this corresponds to which observation in the original data set. So again, just like the filter function, what we're going to do is we're going to give this a new name and we're going to assign it to be an object. So here I'm ordering price from low to high. So I'm going to name this this object or data set to be car seat underscore price underscore LH. And the LH here stands for low high. And so again, this is just a naming convention that I'm using to help me remember what each of these are. You can use different naming conventions that make sense to you. So again, I'm going to arrange car seats by price. That's going to put my data set up here, and then I'm going to view it. And we can see scrolling through here, if we look at price, it has been ordered from lowest to highest. Now, a word of caution here. Up here, you can actually, in the view function, you can click on these and it will reorder the data set by whatever variable you click on, but that only changes it in the view function. It doesn't actually change the data set itself, or, I keep on saying object, in this case the objects are data sets. It doesn't actually change that. It only changes it in this view window. Whereas when we write this code, it's actually creating a data set that has that ordering. Now you might want price from highest to lowest instead. And to do that, instead of putting just price by itself, we put DESC, which stands for descending. So this will put price in descending order. So this time I've named the data set car seat underscore price underscore HL for high to low. And now if we look at price, we can see the highest price is 191, and that corresponds with observation 166. And again, we can do this for more than one variable. So here we have car seat location price HL. So we're going to take the car seat data set, we're going to order it by location, and then we're going to order it from price from high to low. Now location is going to be ordered from low to high. But remember that our location here is really that variable US, which tells us is it in the US or not. So this is only going to take the values 0, 1, or yes, no. So let's see what this looks like. So we first ordered by location, and in this case location means US. So you'll notice if we go to the US, the no's are all first. So if I scroll down here, I'm going to see all the no's for US and then all the yeses for US. And then within each of these, so each of the grouping of no and then the grouping of yes, we're then going to order by price from low to high. So notice the price starts at 185 and continually gets lower as we look at the no's. And then once we get to the yeses, we can see the yes is the 191, so that's the highest price for the yes group, and then it goes in descending order. So just kind of a note here, even though the car seat data set did not have any missing values, if there were missing values, the way that the ordering works is the missing values would be placed at the end. So the next function we're going to look at is the select function, and what it does is it zooms in on a subset based on names of the variable. So select and filter are similar. Filter looks at values of variables, whereas select is going to look at just variables, so not values that variables take, but just variables themselves. So for example, we could use the select function, and we could have our data set, which is car seats, and then we only want the urban and the US variables. So if I run this, notice here that prints down the console again, because just like with the filter and the arrange, we know if we just use the function, it's going to print it down the console. And so notice it's taken the car seats data set and it's just printed the urban and the US. Now, one thing you do want to be careful about is dplyr has a select function, but also the mass function does. So you may have previously had the mass function. So if you were getting some kind of error here, or it doesn't look like what I have, you might need to run this line of code, which is going to detach from the package mass. Okay, so just keep that in mind. This is one of those cases where that masking might cause an issue. And so in this case, I didn't have the mass package loaded, and so I didn't have that issue. But if I did, so let's say I had called the mass function, notice that when I load the mass function, it tells me the object is masked from dplyr, and the function that was masked was select. And so if I come up here and I run the select function again, I'm going to get an error. But if I detach the mass function, and even though I got that error, it still works. So just something to keep in mind, because we've used the mass function in the past, and so if you haven't been clearing your console, you might get an error that looks something like that, and you just need to detach that mass package. All right, so let's look at another example, or continue this example rather. So remember, using the select function by itself is going to print to the console, which isn't terribly useful. We probably want to assign this to be a new data set. So in this case, I'm just going to call it car seats location, and I've included just the two location variables. And so here's what that new data set looks like. So I highly recommend looking at this chapter in the book. If you haven't been following along with the book has lots of other examples and tidbits, as well as other useful helper functions. Highly recommend also checking out the book. It's free, it's online, tons of good information in it. Now the select function, within select, we can also rename some variables that can help us. So here I'm going to call car seats 2, so just a new data set, and I'm going to use what's called the rename function. And in car seats, there is this variable called QUAL underscore SL. So again, here notice that the shelf, this one is not in the data set. I misspoke. The shelf location is in the data set. And so notice it is a factor with levels bad, good, and medium, indicating the quality of the shelving location. So I might want to rename that as qual SL for quality of shelf location. So before I do this, let's look at our car seats data set. I'm going to close out some of these because I've got a whole bunch up here. So I could either use the view function or I could just click on car seats and it will open. So notice we have that shelf location variable right here. I'm going to run this line of code. Now I have this car seats 2, and if I click on it, notice that shelving location has been changed to quality SL. And one important thing here to notice is I didn't want to reuse the name car seats because that would override my original data set. I don't want to override that, so I'm just calling it car seats 2 because I've created a new data set I want to work with where I've renamed that variable. And then we could also rearrange the variables. So let's say I want a data set where I want to start with the car seat data set. I want the first variable to be urban, the second one to be US, and then I want everything else. And so notice I've got everything with open and closed parentheses. So if I click on car seats 3, now notice I've got urban, US, and then all of the other variables. All right, so the last function we're going to look at is the mutate function. And what the mutate function does is it adds new columns to the end of your data set. So again, I'm going to create a new data set called car seats 4. And what I'm going to do is I want to start with the car seats data set, and I want to add a new variable called income in thousands, which is equal to the income variable times 1,000. Running this line of code, clicking on car seats 4, notice here at the end I now have income thousands, which is equal to income times 1,000. And it might be that maybe I only want to keep the new variable. So here I'm going to create a new data set called car seats income, and instead of the mutate, I'm going to use the transmutate function. And again, I'm going to start with car seats, and here the variable income thousands is going to be equal to the income variable times 1,000. And if I double click on car seats income, notice now I just have the one variable. So mutate will add the new variable to the end of the data set, whereas transmutate creates a data set that just has that variable in it. And there's lots of other useful creation functions, so again, do read along in your book. And as always, if you have any questions, let me know. And then again, I just always like to end this video just to remind you, you can't break anything here. Really, the best way to learn coding is to make mistakes, try different things. It can be frustrating, but it's a really important part of the learning process when it comes to coding. So don't be afraid of making mistakes. Don't be afraid to try new things. Google different ways to do things. There's always more than one way to code something. Some are going to be more efficient than others. Some are just going to be a little bit different. But the more that you really just explore these different ideas and you practice this stuff and you try it, you look up new things, you'll find that your skills in coding are going to grow and really fast. Whereas if you just try to do, I don't want to say the bare minimum, but you're not really trying to do different things and explore, you'll find that learning can be a little bit slower that way. So don't be afraid to make mistakes is the big takeaway here. You're not going to break anything. Anything you do can be fixed. And so really try different things and ask lots of good questions as we go along. And that's going to be really the best way to learn coding. I know it can be really intimidating, it can be frustrating at times. But I promise, again, you're not going to break anything, and you'll find that the further we go along in the course, by the time we get to the end, you're going to be like, oh my goodness, if you think of where you started, at the beginning to where you are at that point, you'll be surprised at how much you've learned. So again, keep on asking all of the great questions.